Okay, good afternoon, everybody. In today's class, we're going to talk about the problem number 2, pair up of the USACO 2021 December contest, the Platinum level. I hope you guys finished this round of USACO. Today is the last day of doing the January USACO. There's still a couple of hours left. If you have not done so, I hope you find time after today's class and finish this round of competition. Again, today we're going to talk about problem number 2 of last Platinum competition. For people who are coming to our class in the first time, again, first we're going to explain the algorithm, then we're going to do a pseudocode. The homework left behind is for you to implement the actual code. Okay, so let's look at the problem. Yeah. The problem is you have a list of cows up to 5,000. Each of either be a Holster or Guernsey. Then it's lined of, for example, you have H, you have H, you have a G, you have H, you have a G, so on and so forth. Okay. You can form a pair if in the same breed, for example, G and G, right? They are within a distance of K. Okay. Then you can pair it or unpair it. Then you have to pair it in a way that whatever remaining is unpairable. So for example, if you pair, let's say you have another H here. If you pair this way, this is not a valid end result because you can still pair those two together, right? So, but if you, for example, if you pair this way, right? And let's say if K is 1, that means you cannot pair this against that, then that's a valid end result. That's basically the problem statement, okay? Let's go back to, okay. So if that's the case, we have to pair this and this. Okay. So then they ask for 2 answers. If T, so basically compute the minimum possible sum of the weight. Right? Each of them have a weight, which is, let's say, W of the weight for each one of them. What's the minimum possible weight and what's the maximum possible weight of the unpaired cows when you have the valid result? Okay. First of all, the N is 5,000. Right? What does that mean? I think by now you guys all know, right? That means O(n) squared is okay. Okay. So then the second thing is, if we look at this, obviously we have done problems similar to this before, right? This is a typical DP. In other words, if you find the best result here, when you get the next one, it's possible to construct the best result up to here by all the states from here. So the DP, right? For DP, one is we need to find the description, right, of the state. Right? You need to find the description of state that can clearly describe the a unique situation. Then you need to find the transition from one state to another state. Right? Once you can do that, then you can construct your DP. So let's look at the problem. First, let's look at t equal 1. Okay, t equal 1. That is, we want to find the minimum of unpaired. Minimum of minimum of unpaired. That is the same as, let's find the maximum of paired, right? Where maximum pair, this equals to sum of W minus the maximum paired, right? That's the minimum of unpaired. Okay, so we have two type of cars, H and G. So in order to define the state, obviously we want to define, for example, up to here, right? Up to here, how many, what is the maximum weight? Of course, I mean maximum weight of paired. So if I can define the maximum weight of the paired, it's not enough to say, for example, it's up to 5, or in this case, up to 6, because in 6 you could have, for example, 4H, 2G, 3H, 3G, or so on and so forth. So the minimum to define the state is you need to know, for example, how many H and how many G, right, has happened. Then you need to go to, if you have, for example, 4H, 2G, right? What is the weight? What is the weight? Maximum weight, okay? Maximum weight. And the second thing is you need to find from here to the next state, right? Either H plus 1 G or HG plus 1, right? So in another word, if you have, that's kind of like a two-dimensional array, right? You have H and G. This is your H and G. You need to find how can I get here? How can from, which state before this, right? That I can get to here. Okay, so let's think about it. If you have this much, let's say you have 4H and 2G. This H is defined, we have first H type and the first G type. Right? So there's two, if you add another one, right? If you add another one, there's a couple of ways you can do this. You can choose not to pair the next one, right? So it does not matter is if the next one, let's say if the next one is H, okay? If you choose not to pair the next one, so that means the one before is H minus 1, right? And it's G. And you go from here to here. The weight doesn't change, right? The weight of paired doesn't change because you choose not to pair. Or the same as this, you can choose not to pair. If the next one is G, if you choose not to pair the G, okay, then H doesn't change. You start from G minus 1 to G, right? So you do this way. Or you can choose to pair. If you choose to pair, the previous state is H minus 1, G minus 1. But here's a condition, right? If you choose to pair, that means this H and the G, the last H and the last G, has to be less equal to K, right? As required. So you just need to find, you need to verify if the last one is the distance of last H and last G is less equal to K, then you can then you compare them, otherwise don't. Right? That's a pretty straightforward. That's a pretty straightforward DP, right? So you know, in the case I have above, right? So I have H, H, G, H, G, H, right? So my H is 1, 2, 3, 4. My G is 1, 2, right? So that's my H, that's my G, right? So for example, when I have H equals 3, G equal 2, right? So then what is my previous one? You know, H, what's the location of my H, X of 2 minus my location of G of 1, and that distance is 1. That means, hey, I compare that, sorry, I mean this and this. So this is the third of H and the second of G, the distance is 1. So that means I can pair this up. Okay. So that's pretty straightforward. So now let's look at, okay, so we're halfway there. Let's look at T equal to, okay? So I want to find the maximum of unpaired. Okay. Okay, now again, let's start with dp of H and G, right? Let's see, can we do this? So if it's unpaired, so then the next one, you know, now I have the next one, right? So the next one, let's see, how do we do the transition? If the next, you know, if the next is, let's say the next is H, okay? So we can choose, right? We want to find the maximum unpaired, right? So I want to unpair this. If I choose unpair this, then you go from H to G to H, G plus 1, right? So that you can do. If you choose, if the next one is G, you go from H plus 1, G, and but those two states are different, right? It's like one is next is H, the next is G. How about we add another one? So then this becomes still H, still G. What's my O here? Is ON squared, right? Because this is only 2, right? So that's still ON squared. I mean, ON still times 2, that is still ON squared, right? So that's okay. So if I choose not to pair, okay, I can not to pair. Next one. What if I choose to pair? Okay, if I choose to pair, that's the same as what I did above, right? So I can change if I choose to pair, right? I can go here to here. Okay, so if I choose, then I go from H, G, and you know, next to H plus 1, G plus 1 next, right? So because I choose to pair, remember next is the one I have not paired, right? So for example, I have a bunch of H and G's, right? And my unpaired is this thing. And I have my next H and next G, I pair them. So the unpaired is still the same, it doesn't change. But I could change it. For example, I could pair this and this and leave that. So for example, this is H, this is H, this is G. I can pair this and then the next still H doesn't change. But I could pair this and then I swapped. My next changed from, you know, let's say H, right? So I have H and G, right? Let's say for the next, you know, let's say this is 0, right? This is 1. Okay, so okay, so I could, if I don't change, right? This is no change, no change. So I can also change next, which means I flip, right? I flip this, like this case. I make H and H, but so I switch to G. That is a little bit difficult, right? But not really that much, right? So we can basically, if you look at it, right? So it's basically is if the location of my, let's call it the previous next, okay? Not the best way, but you know what I mean. At this state, the location of that minus the location of the, let me call it the next. I probably should call something else. How about I'll call it B, okay? If this distance is less equal K, right? Then I can pair this together. Then my, next will change, will switch, right? From 0 to 1, from 1 to 0, right? Will switch, okay? So then we're done, right? So you have two conditions. One is you not pair it. Not pair it, you have, you basically stay. Or you can pair it. In pair it, you have two possibilities. One is you don't change it. The second is you change it. Right? Okay. So now let's try to code this. Okay. Let's try to code this. Again, once I code it, I really mean pseudocode. You guys need to implement it as your homework. Right. So the first step is, of course, we will see in all the conditions, right? So we will see in the number of cows, right? So number of cows, X and the Y, right? Meaning, so look at here, right? So for each of them, right, they have the cow, which type of cow it is, right? And the location of that cow, right? And the weight of that cow. Okay. So just make it easy to read. Let's say it's W. Okay. So remember, we need to do a little bit counting. Right? So look at here. We need to do a little bit counting. We need to count, right? Instead of 1, 2, 3, 4, 5, 6, 7, we need to count which one is X, which one is H, which one is G, right? So let's say I have a counter, right? Counter 0, 1, which is for number of H and the number of G, right? So then my my W of for my W, I will say, for example, W0 of 3, right, which describe the weight of the third H, right? 0 is H, 1 is G. Right? The number of the third H, what is the weight, right? So that's easy counting. Okay, so let's do some homework. So then if this type, right? If this what they call it, T, right? If this type if t equals 1, then we will, let's define a function, said find the minimum, okay? Find the minimum weight, okay? So then else is find max. Okay. So then, okay, so now let's first do find the minimum weight. That's the we said it is easy function. Let's see what we're going to do. Find the minimum weight. Okay, if so, we do that, right? I will not do all the initialization and all that stuff. Okay, so basically your for loop, right? Remember we said O(n) squared is fine. H is 0 to count 0. I mean, from 1 to count 0, right? Count 0 is right. 0 represent H, 1 represent G, right? G is from 1 to count 1, right? So what we're going to do? We're going to say dp. Let's call it dp1, okay? First problem, okay? Yeah, H and G, right? That equals minimum of dp1 of H minus 1 G and dp1 of H minus 1, right? So this and this, right? So then say if this thing, right? So we need, okay, here in addition to weight, we also need to have a location, right? So let's say location 0, 3. So meaning for H, right? For H, the third one is at which location? 1, 2, 3, 4, right? Is X of 4, right? So, okay, so this is Y, and that is Y of 4, right? So if this location, right? Location of, the first one is the H that, right? Minus location of that. If that less equal K, right? Obviously absolute value of that. If that equals to K, then dp1 of H and G, right? Will equal to max of dp1 H and G, and dp1 of H minus 1, right? And G minus 1. Then now we're going to pair this, right? We're going to pair H and G together. Then we need to have the weight of that, right? So the weight is this H and this G, right? So that H and that G, right? Okay. So then after that, you just see out there. Okay. So that is my dp1, right? So that is going to be long dp1 of max of V and the max of V. So it's 5,000. So let's find the minimum. Okay, pretty straightforward. Okay, then we have to do find the max weight. So let's see what we said. How do we find the max weight? Might be similar, but we need to have three stages. I mean, 3 dimensions, but the third dimension is only 2 variables, right? So we do the same. what we do. Okay. So the first step is what we say, we're not going to pair, right? Not pairing. Okay. So if we not pairing it, then our how about I put next to the front, okay, just to make it easy to think about it. So if I think about the stage is H, okay, if I think about the stage is H, right, is equal to, it come from G, come from from G minus 1 to G, right? And we're looking for not paired. Okay, so then we have to add this not paired, right? So I mean, from G to G plus 1, we have to add that not paired. So that is the max of itself. Right? And I mean, we're going to go from we're going to go from here to here, right? So H, I'm sorry, this was written wrong. If next is H, then H plus 1, okay? H plus 1, because you have one additional H, right? So you go from H to H plus 1, right? So you go from H, then you have one additional item, one additional H, like me. Right? So one additional H, right? So which is this one, right? You go from here, you go from HG to the one with additional, let me correct it just to make sure we all understand what we're saying here. So because you had one additional H that is not paired, okay? So here you have one additional G that is not paired. So of course you have to do you have to check this H plus 1 is still within still within bound, right? To 0, right? And then we're going to do the max. Make sure you initiate like dp here. Probably we should call it dp2. Okay, just call it dp. That's fine. So okay, the same. And for same for G, right? Which is 1. Right? So you do the same to transition from doing this. Okay, so that's not pair. So next we're going to pair, right? Well, it's in pair, but not switch. Next. Okay, we're going to keep the next. Okay, that's what we're going to do here. So then we need to do if, right? If basically we're going to pair H plus 1 and G plus 1, right? So basically if the location of H plus 1, and remember location is what we did before, right? Minus location of next. If this, right, again, if that is less equal to K, then we can do this pairing, right? So we do from dp, for 0 is from dp 0 h g. We move to dp, again, it's still 0, right? Because we're not switching h. If I start from h, it's still h, right? H plus 1 and g plus 1, right? So since we paired them, okay, there's no additional weight of unpaired, right? Everything is paired. Okay, same for 1, right? So next one is we pair and switch. Okay. So here is a little bit tricky, right? So that means you need to find the previous one. Okay, you need to find the previous one that is pairable with this one. Okay, so I leave that as a little bit of homework, but the concept basically goes like the following. Okay, so how do I find the last one? Okay, so let's assume the next is h. Okay, so let's say, for example, in this case, right? Let's say the next is h. Let's say the next is h. That is at we want to switch the h, right? So we want to switch the next one, meaning next prime. I mean next prime is h. So the previous, that means previous next is t, right? Because we're going to switch. Then we need to find the in order to switch it. It means let's say this one is h, right? So we have to have a one that is at least k distance away from this, right? Otherwise, you can just still pair them, so that's not unpaired. So you need to find one that is at least that away, k away. Okay, so then say next, starting from my hg, right? Let's say my next h, okay, now it's located at some distance away, okay, which is more than k. Then we can go then between here and my next one, right? So for example, now I'm at I'm going to switch, right? So let's say if okay, let's do condition is, let's do a starting from 0 first. Okay. I'm gonna let's start from 1. Okay, 1 is basically g, right? I want to make next is h. So I want to find, basically I want to find another, right? So let's say my next h. I want to find the next h, so that is a away. Right? from previous, and in between equal of H and G, right? So that I can pair whatever in between, and what's left is 2H that is very far away. Okay, that can be calculated. Right? That can be calculated one time, just like what we're doing before for the locations. Then you just sweep from left to right. Right? Every time you find, every time when you do edge, right, you find what is the location of the one before. Let me show you. Let me show you an example of how to do this. So pre-compute. Okay, so we can go from right to left. Okay, so let's say from so we count. Let me use this example. We count from here backwards. Okay, so we do that. So at the, if you look at the beginning, right, I start from here and start from here. What is my last valid pair starting from here? Obviously it's my current, it's just this location, right? Because I'm counting H. Then what is starting from here is that. So let's say my last from this, right? Last from here, X. If X equals count 0, Y equals. So if that, okay. So then in other conditions, let's say if this distance, let's say I'm at here, okay, H equals 3, G equal 2. If I'm going from here, right? If my previous pair, let's say is less than equal to K, then I'm still keeping the same previous pair, right? Because if a previous pair is a valid pair, then it is still a valid pair, right? So it's basically if my absolute value of my location of 0, X, the location of G of Y, right? If that's less equal to K, then my previous valid pair is still a valid pair. Right? Obviously, I mean this one. Okay. Otherwise, that is not a valid pair anymore, right? Then I'm basically starting from fresh. Okay. Okay. So basically, for each of this location, right? H, for example, H equals 3, G equal 2. I can find, counting from this side, what is the next valid one. Okay, then once I have that, then at here, then I just need to find, if I find the last valid one, then I can find the last available too close one, right? So I leave that as a homework for you guys. So if we find the last too close the one, then it's basically, I'm not going to use last valid. I'm use last valid one as example for you to think about it. The last too close one is you can screen, so you can do from here to that way, right? So basically, if for example, if this and this is more than distance, right? More than the distance of k, then you kind of know what is the one, what is too close and what is too far away. Right? So I leave that as a homework. After that, of course, you're going to see out. Okay. So this is, let's look at it again, right? So this is a basically this is a DP. For a line like this, we know if you have we can always use DP, right? The key is you find a way to describe the state and you find a way to transition from state to state. When t equal 1, we're trying to find the maximum paired, right? Which is minimum of unpaired. That is easy, right? So you go, you either not pair the last one, or you find a way to pair the last one. Okay. T equal 1, which is you want to find the maximum unpaired, is a little bit difficult, but not by much, right? So we find out we don't know, in order to completely describe the state, we want to find, we want to have introduce one variable, which is the next unpaired. But that is relatively easy to do because there's only two states. It's either H or G, right? So it will not change your complexity. Still unsquared. Then if it's not going to use the next, if not going to pair the next one, then it's a straight conversion. If you're going to pair it, but pair it from before, that's the same as above. The only difficulty is if you want to change the state. Right? If you want to change the state, then you need to find, if this is the one I'm not going to pair, what is the one that is far away? How far away the next one I'm not going to pair? Then you do the transition. Okay, so hope you had fun with this description. And please complete the homework. Think through how to do the pair and the switch. Again, it's not going to use the last from. Okay, I'm using that last from as example. You have to code your own of looking for the next one, but do it outside of the to for loop, right? Because you only need to calculate it once. Okay, thank you. We will talk next time.